Let's move to the module 2, where we take the model we trained and tracked with MLflow, turn into real scalable service running on Kubernetes. This module is where the mental shift really happens. Until now, we trained model and tracked experiment, but a trained model that cannot be served reliable is not useful in the real world. That's the actual crux of this course. And the model must handle traffic, recover from crash, scale when demand increases. This is exactly this is why Kubernetes exists. So let's talk about why we are doing this. So you cannot run a Python script on laptop and expect it to serve millions of users. So process can crash, machine fails, and traffic is unpredictable. Kubernetes solve this problem by managing containers for us. If a container crashes, Kubernetes restarts it. If traffic increases, Kubernetes can run multiple copies of the same model server. Uh, Now let's talk about what we are going to build here. Um, we are going we will start a model server, which we will write in a very simple Flask application. This server does something very important. It does not bundle the model inside the Docker image. Instead, at startup, it should connect to the MLflow inside the Kubernetes cluster, fetch the latest version called DEM load into memory. This is the key pattern that we should first do, then we'll talk about later. So let's make the file app.py. Let's go inside that file and first thing first, from let's add Flask. Let's import Flask quests and JSONify, import MLflow.sklearn, import pandas as pt, import os. Let's make our Flask, sorry, Flask under name. Now let's define the URI. Let's go ahead and copy it from our training code. Same thing. And model code name. It's what we had our model DEM, and let's MLflow dot set that score tracking URI. Perfect. ML URI. So this much, as we run this file, this much will be done automatically. So let's make our function which is going to load our model. So let's put a try exception is equals to F. That's how in the models artifacts path you can pass the model name slash latest. So what this is actually going uh, to do, it's going to, because we are going to run it this many times, so it's actually going to bring us the latest model file, latest version. So let's make our MLflow client MLflow dot tracking dot ML. I believe it's track Tracking and tracing is different. Tracing is for AI and LLM inference. MLflow client. Now let's get the latest version. So client dot get latest versions, and we can give our model name. If not latest version, so we can throw the error model not found. This is important because if your Kubernetes paths are not correctly set up, it could be a cause why the model will not be getting loaded. And this debug statement will help us for such issues. And we can like in that case, we should return none because like now let's get the model. So MLflow dot sklearn dot load model and the model URI, and then we can return. So this much is important because this is something the uh, MLflow stuff except exception is E, and then we can print any error if it occurs. Let's print the error. If you see any error, you can show you can comment down these in this channel. If you see any error, I'll help you in resolving those, or if why that error occurred. So now what we need is some paths that are actually going to help us in making predictions, like /predict health path, where a machine is healthy or not. So I see a lot of people what they is like, if the /health API is responding, then they assume that everything is correct, but no. You should create your let's first make our global none, so that we are able to access it. The best way of making our health, because it's going to be very useful, your API can be up, but your machine learning uh, models are not ready. This is a real problem, and I have seen a lot of people make mistakes here even in the production, and that creates really a lot of problems. You can have your machine getting scaled and still not serving. So we are talking about real problems here. So how should you do it? Let me show you. Uh, so usually people return OK 200 here. What you should do is only return these status HEALTHY and model loaded as the variable. See, this is important. So there are two things. Your API is healthy, good, and you should run your loaded as model is not none. So it will tell us true or false. If model is actually correctly loaded, then you know correctly what is happening inside your container. Like, so make sure this you do that. And let's, and to save your time, I'm actually going to walk you through the predict code and see slash predict. It is a post method, and we are taking the global model. If the model is not present, it's going to load the model. If model is not, we should also return the ML flow. Is the ML registered or not? Get request, get data frame, model.predict, return the prediction. Python is just the simple machine learning stuff. Nothing fancy here. All the idea should be we should be able to check if everything is working fine, and we should be if we are able to make the predictions. So let's I am not going more in detail into that because we have to build in this tutorial. I wanted to build the Docker container and all, and that's only possible when we can abstract away some of these things. So let's start this server. And also one more thing, like you will see sometimes these uh, statements will not come, so make sure to make flush as true, so they'll get as this execution happens. This your You should be able to see I faced this. If you are not seeing the logs, then just make it flush as true. So make sure if our API is loading, we have a model, and then we can run dot run. Let's go host 0.0.0.0, and let's run this on port 5001. Perfect. We have created a Flask server which is going to serve our model, and once this is done, let's create our Docker file. douch file. We have our Docker file. This is actually going to build our API, and that API is actually it's just spinning up this Flask server. So let's bring a Python 3.9 slim base image, kdir/app, copy stars.txt, and okay, we'll also create a requirements.txt first. It requires MLflow, pandas, and Flask. What else we were using? MLflow, Flask, and let's also like it scikit-learn, and also a Postgres dependency. G2 hyphen ps psi copy G2 binary. Perfect. And now let's come here, copy this requirement, run pip install, and this one is no cache, -r txt. I hope this is correct. And then copy app.py into working directory, expose the port. Let's run the command python start app.py. Awesome. So the thing we have done here is uh, we have created our Flask application, and then we have created the Docker file. So let's first build our Docker uh, image. So Docker build -t diabetes model server latest dot. All right. Oh, sorry, I forgot. So yeah, it's building, and hopefully we will be able to build that. Once this is done, then we can load the image into kind, which is Kubernetes and Docker. Since kind does not use a shared repository, we must locally load the image. And once this command is, it's no cache tr did not complete. All right, let's see. Because we also need to write our K Kubernetes manifest, and I'll actually, once this is done, we'll go there step by step. Um, First thing we'll do, load, once if this runs successfully this time, we are going to create, okay, there's an error. All right, let me dissect this. Did not complete it. Maybe something here, be the requirement are not correct. Let's try one more time. Then we can see the problem here. Perfect, it worked. So the problem was in the requirements file. All right, so now that we have our, we can now load this Docker image into kind. We can pass kind load Docker image type, it's diabetes. I hope that I have not made the typo. Slash model slash server latest. This is what we have built our image. That's the name. Cluster one. So we have to do this image with id not present On cluster control panel, loading, not yet present. Perfect. Great. Now we can create our uh, K8s manifest. K8s manifest.yaml. So this manifests that let me copy. I'll explain you what is happening here. So this manifest defines three critical things. Deployment, which manages replica pod for our model server, a service which provides stable network endpoint, a label selected that ties everything together. So when we are going to run the command kubectl rollout, this ensure the latest image and configurations are picked. Kind, we are going for deployment. This is the server, and we are going to use default namespace. Let's make one replica, and this is the image name that we have selected, and this is the container port, the MLflow tracking URI through internal networking. This is the establishment of internal networking between the pods. And now once, this is a standard template, actually you can get it from internet. This is how you do configuration. For us, everything is matching here. So what we can proceed with our next setup is to apply the skate manifest kubectl apply -f K8s manifest YAML. Perfect. Now we can kubectl rollout status deployment slash diabetes model server, and let's time out. It should not take more than 2 minutes, I guess. Let's put 120 seconds. Successfully rolled out. And now for local testing, we need to actually do port forwarding. So let's copy the port forwarding command. So we should map. Let's first, no, it won't work. Let's kill any existing port forwarding. I'll actually paste all of this uh, uh, in a file, so that now what we are going to do is to develop a mapping from 80 to 500, one of this to 5002. Now we can actually go there, and in our browser, let's test ctp /low localhost in over port 5002. We have ported 5002. Health, yes, perfect. Our model is healthy. API responded. That's actually we wanted. And now we can actually test our model if it is making the predictions. So let's make a post request to that server. So it's a curl request which is going to pass the age, sex, BMI, BP, S1, S2, the feature vector, and we got the prediction. So much hassle for all of this, but this is important because what we are doing is the deployment is to become ready, and this is not for just for the convenience. It's a actual production pipeline. And so uh, provide the all of the commands in a file, and in case you see 403 message or ab- about invalid host header, when model servers, what happens when model server talks to MLflow, this is due to MLflow security middleware blocking internal Kubernetes services. You might see 403. The simple fix is, uh, if you remember the way we have configured uh, the MLflow, so on that case, delete that pod of MLflow we have created. Uh, Kubernetes will already automatically recreate the new pod. The server is going to fetch the new model again. One important reminder here: the model's server depends on MLflow being available. Make sure that your MLflow service on port forward from module 1 from the previous lecture is still running before running the server. So that's why you can see my terminal is still running. You can inspect how you can inspect it. So you can type kubectl get pods. See, your pod is now running, and you can also get the logs. What unexpected log? Oh, you also need to provide which pod. Let's try. See, you're getting the logs from there in the of the pod. So kubectl is very helpful. Uh, and at the end of this model, we have achieved something very critical. You trained a model, you tracked it by MLflow, you registered it in the MLflow registry, and now you're serving it as a scalable self-healing APIs on Kubernetes. So this is the core of real world MLOps. In the next module, we will go one level higher and start orchestration workflow and automation on top of this. So really excited for the coming up lecture. For the This time we are going to introduce you to the airflow. Thank you.